Hello, this is Dr. Rahman Ali, and we are going to implement the relational algebra operator in MySQL and MS Access. So let's first start from the MS Access because it is quite easier to understand by the beginners, and then we will be implementing it and simulating these operator in MySQL. So we already discussed all the operators in our previous tutorial. You can watch from there. These are the basic operator are selection, projection, union, intersection, difference, and union. And some of these operator don't have direct implementation. NMS access, for example, intersection don't have the direct implementation, but it is implemented using inner join, and division needs some complex queries, so we will be postponing it to the MySQL tutorial, and the rest of the operator have its implementation detail. And regarding the join, we have inner join and outer join, and inner join has equi-theta natural join, and outer has left outer and full join, and same is the case over here, that natural join in MS Access and full outer join in MS Access, they don't have the direct implementation, but indirectly they could be implemented. So now let's start with the basic operators. I will have to start one of the MS Access database. This is my database, and I have different tables. You can see that there is a department which has many students, and each student have many courses. Now I am going to apply all these relational operator uh, in here. So to apply it, you have to go to the create, and we have to create the query. So I'm going to start the query wizard, and first I'm going to apply the selection operator. Selection operator is unary operator that operates on a single table. So I am going to apply it on the department table, and from department table I am going to select all these department dot starex, means that all the records need to be retrieved. And when I have added all the columns from the department and I am going to run, so this query retrieves me all the records from the department table. Here I have not applied any query, and I am saving this query is selection operator, selection operator without condition. I have not applied any criteria. But when you want to apply any criteria, you have to do it like this: create query design, and I'm going to apply this department table, and from here I have to add each column separately, and here I'm going to apply the selection criteria, because select operator select a subset of the rows. Here I am writing that select me all those within the criteria. I am writing that where department dot department dot department ID is greater than 3, for example. So this is the criteria: department dot department ID is greater than 3, so it will retrieve me all those records where it didn't work. Let me check what uh, where department ID. Oh, this is not numeric. Where department ID is D3. Now you can see that all the relevant record based on the criteria has been retrieved. So this is the subset of the selection. This is select query. So let me save it. Selection operator with criteria. So this is how we could apply the selection operator and a relational DBMS to select a subset of the record. The second operator that we need to apply is the project operator, and again I am going to the query design, and let's suppose this time I am going to select the course. From course, projection means subset of the columns. So here I am going to select only the course ID and course name, not the student ID. So this is called projection. You can see that only two columns, subset of the column has been retrieved. This process is called projection, and if I need, let me save it, and this is projection with two column. And if I want to retrieve only single column, how I could do it? I can go to the design view back and let me delete the first and use only course name. So here this is the projection, means selection of the single column, and the first one was selection projection of the two columns. The third operator that we use, select project and selection, projection, and then union and intersection. So union is not directly applicable, and for union we have to use the SQL view. So how we could do that? For this case, for example, I have two tables, courses, and these courses are course 1 to course 7. This table contains the courses detail from course 1 to course 7, and this table contains the detail from additional course 10, 11, 12, 13, and it also contains course 4, course 6, and course 7. Now I am going to use the union operator to retrieve data out of these two to combine the courses, course 1 and course 2, into a single table. Now how I could do that? For that, let me first create one query for the selection from the courses as we did it. So let me add the courses, add all the attributes, and run it. This is the selection query, and let me save it. Selection query 1, for example, and then I am going to create another query from this table, create from the course 1, and now I am going to create the second query from here, and when I run it, it has retrieved, it's selected all the rows from the course 1. And let me select query 2. This is my select query 2. So why I have created two queries here? These two queries I created separately because union cannot be implemented directly in this relational DBMS MSX. We need to use its SQL view. So I will open the SQL view of this the SQL view of this query 1. You can see its SQL view is select courses.static from courses, and similarly the SQL view for the query 2. So how we could apply the union operator? So for applying union operator, I will have to create a new query. I will go to the query and query design, and in query design I am applying the union query. So union query is here. When you click on this, you will have this place, and in this place you have to copy the code from the query 1. This is the query which select all the records from the course table, and this is the SQL query which retrieves all the records from the courses 1, and I have to take union out of them. So UNIO in union operator, write down the union operator. Now save this, run this query, and you will see that all the records from both the query 1 and query 2 have been retrieved. Union has been taken, and those who were repeated, they have been taken as only once. So this is how union query could take place. And the union query, this is my union query. Now let's see the intersection query. So for the intersections, we already discussed that intersection, difference. Difference cannot be calculated uh, we are talking about the next query as the intersection. So intersection needs to take common columns, common rows from multiple tables. So as we have two tables, courses and courses 1, and they have different courses, but some of the courses are repeated here. For example, if we see course number, course 4, 6 and 7, they are appearing in course 1, as well as 4, 6 and 7, they are also appearing here. Now I need to take the intersection of these course and course 1. So how I could do that? For taking the intersection, I need to take the inner join, and it is not directly we cannot directly implement them. So what I will do, I will go to create query design, and in query design what I will do, I will add course and course 1 here, and I will, for inner join, what we have to do, we have to create the relationship between these two tables, and then I will click on this line and I will see that join property will appear here. And this is the first option, that only those rows where the value of the field in both the table are equal. Equal means that wherever the values are matching, those records will be retrieved. Okay, and now select columns from any of these table, because they are the same. The tables carries the same column, so add all the columns only from the one table, and then run the query, and now you will see that the result let's make it first save it, intersection query, and now go and run it, and now you can see in both the tables, see course number 4, 6 and 7, they were common and they have been retrieved. Now let's go and run the difference. So we executed intersection, projection, selection, union, and the next one is the difference. So difference, for difference query, we have to go to the create and query wizard, and in query wizard we have an option, find unmatched query wizard. Unmatched query wizard, select it and OK, and here difference mean that you want to find out the difference between two tables. So I am going to find out the difference between two tables, for example department table and the student table. So they need to be they need to have common primary key and foreign key attribute, and on these they have been connected to each other. Now I am going to find out all those records. For example, if I say this is for example, this department is table A, and student is table B, and I want to compute difference between A difference B. So it will give me all those records which belongs to A but not to B. This is the logic of the intersection. So now let's apply it. Let's apply it here. Next, and which column you want to see in the result? I say all the columns. Next, and show the results. Now this is the department without matching student. It means that all those records which belongs to relation department, this was department was our table A difference, student was our table B. So A difference B means all those records which belong to A, to the department, but not belongs to the student, means that department are there but no student have been registered in those departments. So these are the 4 departments, 4, 5, 6, 7 and 8, in which no student has been admitted so far. And if you want to see, just come and see the student table and you will find it. Just open the student table, and yes, in student table you can see that department 1, 2, 3 has the student and the other department don't have yet the student. So this is the difference. And the last operator is division operator, which cannot be directly implemented here and needs advanced manual calculation. So we will be demonstrating them in MySQL. So next we will be explaining the join operator. So wait for that and then watch it. Thank you.